Hello everyone, and welcome to our video on finding the equation of a tangent line where we have a function that is a quotient, so that means we'll need to use the quotient rule. But as a reminder, we find the equation of a tangent line by using this three-step process. In this scenario, step 2 is already done because they gave us the point, and we could verify it. It is the actual y-coordinate there if you plug 2 into the x's. So sometimes step 2 is already done, so that's real great. But number 1 is still the largest portion of these problems. So let's go ahead and find the equation of the tangent line, which is a common question in calculus. So they love asking this type of problem. All right, so our first step is to find the derivative. And then afterwards, we'll plug in our value to get a slope. Okay, so the derivative, well, this is set up to be our high and low. So I use high and low. And so our derivative, f prime of x, is low d high minus high d low all over low low. So that's how I remember it. And you could use different symbols if you prefer. And I'm just going to put the parentheses around each. So it's the low times the derivative of the high minus the high one times the derivative of the low. And there's our high function. There's our low function. Okay, so at this point, I usually will use some colors. I'm just going to put this in blue there. And our low, I'm going to keep in red. So actually, let's go back here and colorize it too. Okay, so this is our rule. So whenever you have a quotient, so this was the quotient rule that we applied because we had a quotient in our function, something divided by something. And then now we're just going to plug all that in. So our f prime of x is, now sometimes we might need scratch work to figure out these, but on this problem, I think it's pretty nice. So we have x squared plus 1 is the low. The derivative of the high, so the derivative of x would be just 1. And then minus the high portion, which is x, times the derivative of the low portion, which we can kind of see is just going to be 2x. Okay, so we have our portions there, and then the low is going to get squared, so x squared plus 1, low is squaring it. X squared plus 1, just like that, all squared. And then, like all derivative problems, we would just need to simplify, so we have f prime of x. The 1 would distribute to give us x squared plus 1. And then this multiplies, and it's still minus, so minus 2x squared. And then all over x squared plus 1 squared like that. And then now that we have this set up, well, we can see there's a little bit of simplifying. And the way I'm going to write it, so x squared minus 2x squared. So that would be minus x squared once it's all done. So we have f prime of x equals, I'm going to put the 1 first though. So 1 minus x squared over x squared plus 1 squared like that. Okay, so this is the derivative. So I'm just clouding it because sometimes they want it. But what we really need still in step 1 is to find the slope of the tangent at the x value. So we have x1 is 2 and y1 is 2/5. So we would plug in the x1 value to find our slope. So still in step 1, our mtan is to plug in the given x value. And on this problem, the given x value is 2. So we'll plug that 2 in to our derivative function. And then now it's just order of operations. So we'd have 1 minus 2 getting squared over 2 getting squared plus 1 all squared. And so 1 minus 2 squared is 4, so it's going to be 1 minus 4 over 2 squared is 4 plus 1 would all get squared. And then this is negative 3. Down below, 5 squared is 25. Okay, so we now have our mtan, which I'm just going to write here to the side. I'm going to box it. It's nice to have. Okay, so there we go. So we have our slope. And then we already have the point, so they already gave it to us. So step 2 is usually find the point, which is usually just plugging in your x value in to your original function. But they already told us it, so it's 2 and 2/5. So I'm just writing it like that just to show, hey, that is what we would have done normally. But again, this was already answered for us. So our point is 2 2/5. All right, and then now that we have a slope and we have a point, our third step is the line equation, which I usually use y minus y1 equals m times x minus x1. And again, I boxed this down here too so I could see it and not have to scroll. But we have our slope. So the slope is going to go right there. And then our x1 and y1 are going to go right there and right there. And so now we'll plug all that in. We have y minus y1, which is 2/5, equals the slope, which is negative 3/25, x minus x1, which is 2. And then now we just need to solve for y. So we distribute on the right. So we have y minus 2/5 is equal to negative 3/25 x. And then negative 3/25 times negative 2 would become positive. 3 times 2 is 6. And then 25 still in the denominator. And then our last step would be to add that 2/5 on over to both sides. Okay, and so when we do that, so our scratch work, we would need to add these two together. So 6/25 plus 2/5. I would need to multiply both top and bottom of the second fraction by 5. So we have 6/25 plus 10/25 gives us 16/25. Okay, so that's what that would simplify into. And then we have our answer. So y is by itself equal to negative 3/25 x plus that 16/25. And there we go. Okay, so again, when it comes to tangent lines, finding the equation of a tangent line, it's always this process. Usually, they do like it a lot, and we'll see it as we progress still. The only thing that usually changes is this function gets a little harder each time to deal with. Okay, so on this one, we needed the quotient rule. So we just still want to recognize if you see whatever rule needs to apply it. So whenever you have something divided by something, usually the quotient rule is where we want to go. Okay, so that's it. If you do have questions, please let me know. Otherwise, thank you for watching.